Hello everyone, welcome to the next lecture on the complex analysis. Today I will explain you how you can solve the various examples related to the argument principle. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel where you can find the playlist of the complex analysis. You can see the complete theory lectures as well as the CSIR net examination solutions all are available in this playlist with the help of the easiest way. You can follow and subscribe my YouTube channel. Now, in our last lecture, we have discussed the concept of the argument principles, and today I will explain you the 15 plus examples as well as the CSR net and the gate examinations questions too. You can watch the video till the end so that you can learn how you can solve the examinations paper in a very simple manner. I also hope that you can like and comment on the video as well. If I quickly recall you the concept of the argument principle, if f is my analytic functions inside the simple contour C, then you can find the value of the integration f dash over f is n minus p, where n is the number of the zeros, p is my number of the poles. And again you can see the coefficient of the f dash over f is my 1. But if you can generalize the argument principle, if I consider the another analytic function g, then you can define the generalized argument principle by using the equation number 1. Again you can see n is my number of the zeros and p is my number of the poles. Very special case is that if I consider the g of z is my 1, every constant function is my analytic. This implies the generalized argument principle reduced to the argument principle. Based on this simple concept, I will solve 15 plus examples in this lecture as well as the CSR net and the gate examinations questions in this video. Now let's start with the first questions. First of all, for the given function f, can you find the value of the f dash easily? Definitely not. Why? Because it's a ratio of the two parts, and it's not an easy target you can find the f dash. Once it is not an easy target, can you find the value of the f dash over f easily? Again your answer is no. So whenever such kind of the situation occurs, your target is always apply the argument principle. How you can apply the argument principle? Firstly, you can look about the domain. Your domain is circle, so I can draw the circle of radius 3. Fine, and this is my shaded portion. Then your target is to find the value of the f dash over f. I can apply the argument principle. Now your target is to find the zeros of the fz, and your target is to find the poles of the fz. Fine. So whenever your target is to find the zeros of the fz, you can always consider the numerator part is my 0, and whenever you are trying to find the poles, your target is to find the value of the z corresponding to denominator is 0. How you can find the number of the zeros? You can see the numerator part is z square plus 1 of whole square is my 0. So let's firstly start with the number of the zeros. Can you find the value of the z square? Plus 1 is 0. Can you find the value of the z? Z is my plus minus iota with multiplicity. So can you find the multiplicity? Because you can see the power of the given function is my 2. So multiplicity is my 2. Now check whether the zeros lies inside the circle or not. Always remember the argument principle always work inside the circle. Now check whether z is equal to iota, z is equal to minus iota, whether it lies inside the circle or not. So clearly say what is the value of the mod of z? 1. In this case it is also 1 and it lies inside the circle. So therefore both the points are lies inside the circle, and the value of the n is my, so iota is my 1. Fine. These are the multiplicity 2. So the answer is 2 plus 2. N is my 4. Fine. Why is a 4? Because the answer is iota. They have the multiplicity 2. So iota minus iota, iota minus iota. So you have the 4 number of the zeros. Similarly, I can find the number of the poles by taking denominator part as a 0. Can you find the value of the z? Z square plus 3z plus 2 is equal to 0. So I can factor them. Z plus 1, Z plus 2 is equal to 0. So that implies Z is equal to minus 1, minus 2. What is the multiplicity? Multiplicity is my 3. Now check whether they are lies inside the circle or not. What is the mode of Z? Is a 1 and 2. 1 lies here and 2 is both are lies inside the circle. So can you find the number of the poles? So each has the multiplicity 3. That means 3 plus 3. P is my 6 is the right answer. Now substitute both the value here. P is my 4 and N is my 4. P is my 6. So answer is minus of 2. And what is the value of this? I can multiply 2 pi iota on the both side. Your answer is minus 4 pi iota is the correct answer. Look at the second one. Again, you can see it's a very complex functions. You are unable to find the value of the f dash easily. Draw the circle. Clearly say 2 and minus 2. These are my circle. Now, again, your target is to find the value of the f dash. So I can apply the argument principle. Can you find the zeros of the f? What is the zero of the f? I can substitute. The numerator part is my 0. This implies z is equal to minus 1. This implies z is equal to minus 7 with multiplicity 5, and the last component applies z is equal to iota with the multiplicity 2. Fine. Now out of that, which one lies inside the circle? Corresponding to the first part, z is equal to 1. It lies inside the circle. Corresponding to the second part, z is equal to 7, which lies outside the circle. This point is my lies outside the circle. While z is equal to iota, mode of z is my 1, which also lies inside the circle. So what is the n? Because it lies outside the circle, so it has the simple. So answer is n is my 1. It has a multiplicity 2. So the value of the n is my 3 is the right answer. Can you find the pole? I can substitute the denominator part 0. This implies z square minus 2z plus 2 is equal to 0 with multiplicity 2. What is the answer of this? It's a minus of iota with multiplicity 8, and z is equal to 5 iota with the multiplicity 8. Can you find the roots of these equations? So I can find the root is minus of b plus minus b square minus 4ac divided by 2. So that will be 2 plus minus 2 iota over 2. So that means 1 plus minus iota. So I can say that z is 1 plus minus iota with the multiplicity 4 and so on. So now you can check which one lies inside the circle. So what is a plus minus iota? This is 1 plus 1 2, which is 1.414. 1.414 lies. Yes, it lies inside the circle. What is the modulus of this? Which is my 1. Again it lies inside the circle. 5 of iota, the modulus of the z is my 5, which lies outside the circle. So you can see 5 of iota lies outside the circle. So the multiplicity is my 4 plus 8. 4 plus 8 is my 12. So the value of the n we have obtained is, the value of the n is my 3. The value of the p is my 12. So this is my 4 minus 12. That is minus 8. Fine, this is 4 minus 12. It's a 8. 8 to a 16 is the 8. Sorry, 9. 9 to your 18 is the right answer of the problem. Whenever n is my 3, you can see what is the n? N is my 3. So n is my 3. 3 minus is a 9. So 9. 9 into 2 is 18. Minus 18 pi iota is the right answer. Look at the third questions. Again, you can draw the circle. Circle of radius 4. Can you find the zeros? And you can find the pole. Because it's f dash over f, you can apply the argument principle. So clearly say the 0 is my z minus 1 is 0. That implies z is equal to 1. And 1 is lies inside the circle. So it lies inside the circle. So therefore, and multiplicity is my 1. Therefore, n is my 1. Can you find the poles? This implies z is equal to 0 is simple 0. Fine. Or you can say is a simple pole, and z is equal to 2 is my pole with the multiplicity 3, and 2 is also lies inside the, and 0 lies also inside there. So the number of the poles are, my 0 is a simple and 2 is a multiplicity 3. So the answer is P is equal to 4. I can substitute both the values by the argument principle. The answer is 1 minus 4, which is minus 3. So I can multiply by 2 pi iota. The answer of the f dash over f is my minus 6 pi iota is the right answer. I hope you can like and comment on the video as well. Now let's start with this GATE examination paper. What is given to you? Z is a gamma is a curve of, I can take it as a 2 plus 4 cos of theta. This implies Z minus 2 is equal to 4. Fine. You can see I can write this number is Z minus 2. Z minus 2 is equal to 4 cos theta. So this number is lies as Z minus 4 is less than equal to 4. That means your circle is, center is my 2. Sorry, instead of the 0, what is that? This is my center. Fine. Center is my 2, radius is my 4. So it is my 6 and it is my minus 2. Fine. 4 and 2, 6. Is it okay? Now you can see for the case of the I1, dz over z minus 1 over the gamma. Now clearly say if I consider f is my z minus 1, what is the f dash? Which is my 1. So basically this function is over the curve f dash over f. Fine. So can you find the number of the zeros? So clearly say for the function f, the zeros is my z minus 1 is equal to 0, z is equal to 1, which lies inside there. So it is my 1. Can you find the pole? Because there is no denominator, pole is my 0. So what is the answer of this case is 2 pi iota into n minus p. So the answer is 2 pi iota. Similarly for the second case, the number of the poles is my 3. 3 lies inside the circle. So number of pole is my 1. Number of the 0 is my 1. Pole is my 0. So I2 is also my 2 pi iota 1 minus 0. So this implies I1 is equal to I2. So B is my correct answer. This is the first method. Second method is, again you can draw the circle. Fine, this is my center is 2, radius is my 4. You can apply the Cauchy integral formula as well. So if for the case of the I1, 1 over z minus 1. So clearly say z is equal to 1 lies inside the circle. So the answer is 2 pi iota into 1. Similarly for the I2, you can write as a 2 pi iota into 1. So again this implies I1 is equal to I2. Either you can apply the Cauchy integral formula, either you can solve the problem by the residue theorem, that we will discuss theory class in the next lecture. You can also apply the argument principle for this particular case. So the right answer is B is my correct answer. Look at this another one. Gamma is a circle, so I can write in terms of the z. Z is equal to k iota k of theta. So that implies mod of z is my k. Is it okay? Now for each of this, so clearly say for the k is equal to 1. What is my circle equation is equal to 1, and the value of the gamma or the value of the z becomes my e raised to power iota theta. So what is the value of 1 over z? Again there are the two ways. If you want to apply the argument principle, if I consider f is my z, clearly say f dash is my 1. So this expression becomes f dash over f. So can you find the number of the zeros? So what is a circle? Center is 0, radius is my 1. So zeros is my z is equal to 0 and it lies inside. Therefore n is equal to 1. There is no denominator, pole is my 0. So the answer of this problem is 2 pi iota 1 minus 0, which is 2 pi iota. But he said 0. That's a wrong answer. Fine. Look at the second part. What is the answer of this case is, if I divide it by 2 pi iota, so the answer is my only 1. Fine. So for the gamma 1 is a 1 fine answer. Now look at for the gamma 2, whenever k is equal to 2. So whenever k is equal to 2, your value of the z is twice e raised to power 2 iota theta. So that means z is equal to 2. So I can draw the circle with the radius 2. Now again for the gamma 2, your f is my z, f dash is my 1. Again by the argument principle, the value of the 1 over 2 pi iota f dash over f is n minus p. So can you find the number of the zeros? Is my 1? There is no pole. This is 0. So answer is 1 minus 0. But you can see the angle is 0 to 2 pi. But it's a 2 theta. So what is the value of that 2 theta? This lies between 0 to 4 pi. So that means it is my 2 times rotations. So the answer of this problem is multiply by 2. So the answer is 2. But he said 4. That's the wrong answer. Now for the gamma 3. Now you can see for the gamma 3, that is when k is equal to 3, your z will be 3 e raised to power 3 iota. Your circle will be my fine. Now again for the curve 1 over z, f is my z, f dash is equal to 1. So number of the pole is my number of the 0 is 1, pole is my 0. So the answer of 1 over 2 pi iota over the curve gamma 3. This is my n minus p. What is the n? N is my 1, p is my 0, which is 1. But what is the value of the 3 theta? 3 theta is lies between 0 to 6 pi. So that means it's a 3 times rotation. Fine. So I can multiply this answer by 3. So yes, the right answers are B and D are the correct answers. Okay, look at this one. This is a CSIR net examinations. P is any positive integer. Consider the closed curve. So clearly say the mode of z is my 1, which is a circle. Then again your target. Now you can see it's a multiply by this. I can apply the generalized argument principle. Fine. So what is the generalized argument principle? 1 over 2 pi iota f dash over f into g, which is nothing but summation of the g of the number of the zeros. Fine. Number of the zeros into number of the zeros minus g of number of the poles into pole. Now what is that? F has a 0 only at the point z0. That means number of the zeros are only 1, because the only 0 at the point z0 with the multiplicity q. Fine. So number of the zeros are my q, because it has a multiplicity q. Again the function is my holomorphic, so number of the poles are my 0. I can substitute the value. This number is my 0, this is the only 0. So what is the g? If you compare them, g is my z at the point z0. Find number of the pole is my q. So the answer is q into z0 by raised to power p is the right answer of the problem. Okay, verify the argument principle for the function over the unit circle. Mod of z is my 1. So I can draw the circles and your target is to verify this component. So let's start with the firstly number of the zeros. Can you find the number of the zeros? Zeros means the numerator part is my 0. What is the numerator? So which is not possible. That means there is no number of the zeros. Can you find the number of the poles? Pole is my denominator part 0, and clearly say both the values lies inside and on the circle. So number of the poles are my 1 iota minus iota. Number of the poles are my 2. Now your target is to verify that. That means your target is to find the value of f dash. Can you find the value of the f dash? It's a quite easy. You can apply the product rule. F dash over f. I can find the value of the f dash. It is z square plus 1 of whole square minus of 2z. Now I can substitute the value of the f dash and f in the left hand side. Fine. Now you can integrate over the curve C over the curve C. How you can integrate that? How you can integrate that is again a very simple. I can better I can convert into the partial fractions, z plus iota, z minus iota. Fine. I can break them. I can use the partial fractions, 1 over 2 pi iota. So over the curve, over the point, z is equal to minus iota. So this is my 2 iota, z plus iota, and minus of 2 iota. Fine. Plus, I can use the partial fractions. So it is minus of 2 iota, and z minus iota. So basically that means that 2 iota will be cancelled. So that is a minus, and again it's a minus of this. Now can you apply the, now you can see I can apply the Cauchy integral formula here. The integration of the first part is my minus 1, integration of the second part is my plus 1, and both the poles iota minus iota lies in the on the boundary of the circle. So the answer is minus 1, which is same as of the n minus p. Therefore argument principle verified. Evaluate the function integration of tan by using the argument principle. Fine. How you, because you have to apply the argument principle, I can write as a sine over cos z. What is that? It's a circle with the center pi over 4, pi over 2, and the radius is my 1. So this is the equation of the circle. This value is my 1 plus pi over 2. This value is my 1 minus pi over 2. Clearly say, if I consider f is my cos z, the value of the f dash is minus of sine z. I can write this function is f dash over f. Fine. Now once you can see it's a f dash over f, I can apply the argument principle on the right hand side. So can you find the number of the zeros? The zeros is my cos z is 0. That means z is my 2n plus 1 pi over 2, where n is my integers. Fine. So I can substitute the value of the n. When n is equal to 0, answer is plus minus pi over 2, n is equal to 1, 3 plus minus pi over 2, plus minus 5 pi over 2, and so on. So out of these poles, you can see the only value which lies inside the circle is only pi by 2, because the rest values is my plus minus 3 pi over 2 that lies outside the circle. So therefore your value of the n is my 1. Now can you find the pole? How you can find the pole of the f? Pole means denominator part is a 0, but clearly say the function has no denominator part. Therefore p is my 0. So I can substitute the value by the argument principle. It is 1 over 2 pi iota is n minus p. N is my 1, p is my 0. So therefore it is 1 minus 0. But here this value, the value of this is my 2 pi iota. Because of this negative sign, answer is my minus 2 pi iota is the correct answer. Look at the next one. Again, your target is to find the f dash over f circle with a radius 0, with the center 0, radius is pi. So I can draw the circle. Can you find the zeros? Zeros means the numerator part as a 0, sine of pi z is 0. Can you find the value of the z? This is my n pi, where n belongs to the integer. So that means the value of the z is my n, where n belongs to the integers. Fine. Now clearly say the value n is equal to 0, n is equal to plus minus 1, plus minus 2, and so on. So this value is my 3.14. So clearly say the values are my 0, plus minus 1, plus minus 2, plus minus 3 are all lies inside the circle C. Can you calculate the number of the poles? This is a 1. So the answers are 0, 1, minus 1, 2, and here. So what are the answers? 3, 6, and 7. So n is my 7. Can you find the pole? Clearly say that there is no denominator, so pole is my 0. Therefore, by the argument principle, I can write as n minus p. N is my 7, p is my 0. So the answer is 1 over 2 pi iota. I can multiply them. Answer is 14 pi iota is the correct answer. Now look at the next CSIR net or the gate examination paper. Again, you can target is f dash over f. Your f is z cube into e raised to power z square. Can you find the zeros? Clearly say that 0 says z cube e raised to power z square is 0. But we all knows that e raised to power z square can never be 0. That means z cube is my 0. That implies z is equal to 0 with multiplicity 3. What is the circle? You can see from this case mod of z is my 1. This is my curve and the 0 lies inside the circle. So the number of the zeros are my 3. Can you find the number of the poles? Clearly say there is no denominator part, pole is my 0. So the answer is n minus p, which is equal to 3. But you can see the rotation is my 0 to 2 pi. Angle is theta. It varies from 0 to 2 pi 4 pi. That means 2 times rotation. So the final answer is 3 multiplied by 2 times rotation. Remember, this is my rotations. How many times you rotate the circle? So the correct answer of the problem is 6 is the right answer. Look at this another one. The value of the integral where c is a circle of radius 2 and center is 0. Fine. So I can draw the circle, radius 2, center 0. Now again you can see it look like the function f dash over f, but make sure I have to multiply and divide it by 101. Then clearly say if I consider the value of the f is z raised to power 101 plus 1, then f dash will be 101 into, fine. So that means you can apply the argument principle very easily. So can you find the number of the zeros? What is the zeros? You can substitute the numerator part as a 0 plus 1 is equal to 0. That means the roots are my minus 1. Fine. So all are my simple roots. So number of the zeros are my 101. All the values lies inside the circle. Can you find the number of the poles? So clearly say there is no denominator. So the pole is my 0. So therefore by the argument principle 1 over 2 pi iota f dash over f is my n minus p, which is 101, and your target is to find the value of the f dash over f 101 into 2 pi iota. But I have to divide it by 101 also. So the answer of the problem is 2 pi iota is the right answer of the problem. I hope you can like and comment on the video as well. You can see this is some recent year papers. F is a meromorphic functions with an open set containing the unit circle. Fine. Suppose f has no zeros and no pole on the circle. Fine. And p and 0. This is my number of the poles of the f. This is the number of the zeros of the f. Then which of the following statement is my true? Again you can see if I simply take the function g is my z into f, then all these options are look like g dash over g. That means you can apply the argument principle. So your target is to find the number of the zeros of the g, number of the poles of the g. So can you find the zeros of the g? So zeros means I can substitute the numerator part is my 0. This implies z is equal to 0 and f is equal to 0. This implies how many zeros of the function f? F has the n 0 is the number of the zeros, and this is my z is equal to 0. So can you find the total number of the zeros of the g? 1 plus n zeros. Can you find the pole of the g? Because the denominator is 1, so the number of the poles is my same as of the f. Fine. So the pole is nothing but my pole of the f. So pole is my simply n of p. So I can substitute the value n minus p. 1 plus n0 minus np is the right answer of this problem. 1 plus n0 minus np. A is the right answer of the problem. Okay, next question is for the given function f over the unit radius circle. So you can draw the circle and your target is to find the number of the zeros and number of the poles. How you can find the number of the zeros? I can take z4 plus 2 is equal to 0. How you can find the poles? Z square is equal to 0. Can you find the value of z4 which is minus of 2? The value of the z is my minus of 2 raised to power 1 over 4. Fine. And clearly say this value will always be greater than 1. Why? Because what is the product of the root? We all know if you have the equation ax4 bx cube cx square plus dx plus e, then if x1 x2 x3 x4 are the roots, then the product of the root will be e over a, and clearly say that e over a is my 2 which is greater than 1, so which lies outside the circle. So therefore there is no number of the zeros lies inside the circle, hence n is my 0. Can you find the pole? Pole is my 0 comma 0 and 0 lies inside the circle. So therefore number of the pole is my 2. That is a 0 with the multiplicity 2. So I can substitute the value in the argument principle, wherefore n minus p is minus of 2. So right answer is 2 minus 4 pi iota is the correct answer. Look at this another one. Again evaluate the f dash over f over the unit circle. Again you can draw the circle, find the zeros, find the pole. What is the zeros? Plus minus iota, and plus minus iota is lies inside and on the circle. Therefore number of the zeros is my 2. Can you find the pole? Clearly say the pole is my plus minus iota divided by root 2, and mod of iota by root 2 lies inside the circle. Therefore number of the poles are also my 2. So the right answer is by the argument principle. This number is my n minus p, which is 2 minus 2 is a 0 is the right answer. We will see the next lecture on the residue of the function. That's the most important topics of this complex analysis. Till then you can watch my this complex analysis part theory lectures as well as the CSIR lectures completely with the help of the shortcut tricks. I hope you can like, you can share this video with your friends. Best of luck students, and thanks for the watch.